Welcome back. Let's summarize the integrals of powers of tangent and powers of secant. So if you have the integral tangent to the m of x times secant to the n of x dx, then here's a summary. And it's not going to be a perfect summary like it was with sine and cosine, but it'll get you through a lot of these problems. So if n is even, then we're going to save a secant squared with the dx. So if your secant has an even power, we'll save a secant squared x. There will still be an even power of secant left. And then we're going to use the trig identity, the tangent squared plus 1 equals secant squared, to replace all of the rest of the even power of secant into tangent, and then let u equal tangent, because the du of secant squared will be right there with the dx. Now if tangent is odd, then we can save a secant x tangent x. That will make the power of tangent even, and then we'll be ready to, so then you can convert all the rest of the tangents into secants, and then we can let u equal secant x, and the du will be right there. It'll be the secant x tangent x. Now that doesn't handle all the cases, so here are a couple other ones. If m is even, so if you have a even power of tangent, and this is assuming that the secant is not even, if n is even or m is odd, so if secant is even power, or if tangent is an odd power, you can use these first two and you'll be good to go. But if you have an even power of tangent and an odd power of secant, well, then you can try using the trig identity tangent squared plus 1 equals secant squared to convert the even power of tangent down into even powers of secant. Even powers of secant are a little easier to deal with, as we saw. So you can rewrite tangent squared x, integral of tangent squared x dx, as the integral of secant squared x minus 1 dx. Notice that makes it easier to integrate because the integral of secant squared is tangent, and the integral of 1 there is just x. And then if n is odd, so if you have the secant is an odd power, you can also try using integration by parts. And there's an example 5 here below. We're going to have to make use of that. One thing to note is that the process is very similar to cotangent to a power times cosecant to a power. And that's because the properties are very similar for cotangent and cosecant, and the derivatives are as well. You'll have an extra negative sign floating around because the derivative of, say, cotangent is negative cosecant squared, but they'll work out very similarly. All right, let's head to example 5. This is an infamous example, the integral of secant cubed x dx. And the first thing we're going to do is use this last part right here. If n is odd, you can try using integration by parts. And so that's what we're going to do right here. We're going to try using integration by parts. Notice that we don't have an even power of secant. We don't have an odd power of tangent. So we've got to use one of these later techniques. And here we're going to use the last one. We're going to first try starting with integration by parts. So the way we're going to split up the parts are like this. We'll write secant x times secant squared x dx. So the u here we're going to let be secant x, and then the dv will be the secant squared x dx. Okay, and we're going to use tabular integration just to save us a little bit of writing. So off to the side, we'll do the tabular integration. We have our u, which is secant x. We have our dv, which is going to be like the secant squared x. Now the derivative of secant x is secant x tangent x. That's the mnemonic. And then the integral of secant squared is tangent x. Again, the mnemonic. So to pull out of integration by parts, we'll go across the diagonal, and then this last row here will have this minus. That'll be like what's left in our new integral. So what we end up with is the integral, is uv, so that's secant x tangent x, minus the integral of v du. And so here we're going to have secant x tangent squared x dx. All right. Now we can look at our new integral and see what we can think about doing. Now in this case, we can think Well, the tangent has an even power. So let's try bringing the power of tangent, converting the tangent into secant by replacing tangent squared with secant squared minus 1. So we're going to replace tangent squared with secant squared minus 1. So we'll have secant x tangent x minus the integral of secant x times secant squared x minus 1 in parentheses, and then dx. Now at this point, we've got an integral that has just a bunch of secant x's in them. We can distribute the secant x in. So we'll distribute the secant x in, and we'll go ahead and split up the integral too. So it'll look something like this. We'll have the secant x tangent x minus the integral of secant cubed x dx, and then plus the integral of secant x dx. Why plus? Well, because we have this negative here that distributes to this negative here, and that creates the plus. Minus the negative is plus. So we have the secant cubed x term, the secant x term, and then we're all distributed out. Now, something interesting to note is that we now have the integral that we started with. We started with the integral of secant cubed x. We see that again as secant cubed x. This might remind you of back in 7.1, integration by parts, where we took the integral of e to the x sine x, or e to the x cosine x, I can't remember which one. And we had to do integration by parts a couple of times, and we ended up with the same integral that we started with. Our technique there was to bring both of the integrals to the same side of the equation, and then divide by some kind of coefficient. And that's exactly what we're going to do right here. Let's write out a step here to help us out. So we're going to write the left-hand side, which is secant cubed x dx, is equal to the right-hand side. So that's all of this stuff, the secant x tangent x minus and all this other stuff here. So we have secant x tangent x minus, I'm going to highlight this integral, secant cubed x dx. And then plus the integral of secant x. Well, let's take a moment to figure that out. The integral of secant x. We'll take this off to the side. Integral of secant x dx. There's a trick to this one. This is not one of your easy integrals. There's a trick to turning this into a substitution kind of integral. And the trick to doing that is to multiply the top and the bottom of this fraction. Right? Secant x you can write as a fraction. It's just secant x over 1. You can multiply the top and the bottom by secant x plus tangent x. So here we're going to get secant squared x plus secant x tangent x over secant x plus tangent x. So once again, what we did to go from this step to this step is we multiplied the top and the bottom of this fraction, secant x over 1. I'll write the over 1 here. We multiplied top and bottom by secant x plus tangent x. And then we distributed the secant x to the secant and the tangent on the top. And then just wrote secant x plus tangent x on the bottom, because that's what you get when you multiply it by 1. Then what we can do is a u substitution. Let u equal secant x plus tangent x. And the du is actually right there on the top. It's going to be secant x tangent x plus secant squared x dx. Definitely tricky. I will agree with you there. It's tricky. But doable at the same time. So here we're going to have 1 over u du. So this is ln absolute value of u. Technically there's a little plus c here. And then we have ln absolute value of secant x plus tangent x. There is some motivation here when you're thinking about this, like when you're trying to integrate secant x and you're thinking, okay, well, that's not really the result of the derivative of secant or tangent, and so really what you need are secant squareds and secant x tangent x's for you to do a substitution of any kind. And after some fiddling around, maybe much fiddling around, you can come up with secant x tangent x would be something that you can multiply top and bottom by. Okay, now this I know is a trick, and so on quizzes and tests I'm actually going to give you the integral of secant x and the integral of cosecant x, which works in a very similar way. So I'll give you this integral. I just wanted to cover this so you can see what it looks like. The reason I'm giving it to you is because rederiving it is quite a bit of a trick, and so I'll give you the integral of secant x, which is ln absolute value of secant x plus tangent x, and then plus a little c here. So we'll write that here. Integral of secant x turned into ln absolute value of secant x plus tangent x. So now we're looking at the equation integral of secant cubed equals secant x times tangent x minus the integral of secant cubed plus the ln of secant x plus tangent x that we just found. Now what we can do is bring both of the integral of secant cubes together by adding integral of secant cubed to both sides. So we'll get 2 times the integral of secant cubed dx on the left side. And on the right side we have secant x tangent x plus ln absolute secant x plus tangent x. As a last step, all we'll do is divide by 2. So we have 1/2 secant x tangent x, and I'll open up parentheses here so we don't have to distribute the half. And whoops, I distributed the half. Okay, so we have 1/2 times parenthesis secant x tangent x plus ln absolute secant x plus tangent x. And don't forget your plus c, because this is an indefinite integral. Whew, that was a toughie. But you'll want to know how to integrate secant cubed because it will pop up here and there throughout the rest of the semester. You want to be able to handle this one. Plus, if you can handle this one, boy oh boy, you can handle just about anything. Thank you so much for watching, and see you next time.